In eastern China, where rivers meet the sea and the land slowly disappears beneath powerful tides, a structure is taking shape that most engineers would have once considered impossible. This is Hangzhou Bay, a place known not for stability, but for constant motion. Vast tidal surges, violent currents, and a seabed that never truly settles. And yet here, rising from one of the most hostile marine environments on Earth, China is building the world's longest sea-crossing high-speed railway bridge. Stretching more than 29 kilometers across open water, shoals, and coastal embankments, the Hangzhou Bay Cross-Sea Railway Bridge is not simply a feat of size. It represents a fundamental shift in how and where high-speed rail can operate. Because this bridge does not carry cars moving at highway speeds. It carries trains designed to travel at 350 kilometers per hour, with precision measured not in centimeters, but in millimeters. Building a bridge across the sea is already one of the hardest tasks in civil engineering. Building one capable of supporting high-speed rail pushes that challenge into an entirely different category. Please take a moment to subscribe and like the video. It really helps the channel. To understand why this bridge exists at all, you have to look beyond the bay itself. China's high-speed rail network is designed to function as a national framework, linking a system of major corridors that link the country's most economically active regions. One of the most important of these is the Yangtze River Delta, home to tens of millions of people and some of China's most productive cities. For years, Hangzhou Bay acted as a physical break in that system. Rail traffic moving between Jiangsu province in the north and Zhejiang province in the south was forced inland, adding distance, time, and congestion. The bay was simply too wide and too unpredictable for conventional rail crossings. The Hangzhou Bay Cross-Sea Railway Bridge changes that completely. It forms the critical centerpiece of the Nantong-Suzhou-Jiaqing-Ningbo high-speed railway, creating a direct north-south rail corridor across the bay for the first time. Once complete, trains will cross Hangzhou Bay in roughly 10 minutes, fundamentally altering how the region connects and moves. But solving the geography was only the beginning. Hangzhou Bay is not calm water. It is one of the most powerful tidal bays on the planet, shaped by the interaction of the Qiantang River and the East China Sea. Tides here can rise and fall by nearly 9 meters in a single day, with currents that reverse direction and surge at extraordinary speeds. The bay is also famous for the Qiantang tidal bore, where walls of water race upstream with enough force to reshape the riverbed itself. Add to that frequent typhoons, high winds, and a seabed made up of deep, soft marine sediments, and the scale of the challenge becomes clear. In this environment, even small structural instability can grow into a serious risk over time. For high-speed rail, where track alignment must remain stable over decades, there is almost no margin for error. Most long sea crossings around the world are built for road traffic. Road bridges are allowed to flex. Vehicles can tolerate vibration, movement, and uneven settlement. High-speed trains cannot. At 350 kilometers per hour, even tiny imperfections in the track can affect safety and comfort. That is why this bridge uses a ballastless track system, a rigid concrete-based design more commonly found in tunnels and urban viaducts. Using ballastless track offshore is extremely rare. Temperature changes, wind loads, salt corrosion, and long-term foundation movement all have to be controlled to an extraordinary degree. Yet this bridge not only attempts it, it sets global benchmarks in doing so. The Hangzhou Bay Cross-Sea Railway Bridge is not one structure, but a continuous system of large-span bridges and approach viaducts working together as a single machine. The total length reaches 29.2 kilometers, including 3 major navigation channel bridges and more than 26 kilometers of approach bridges. The railway itself is double-track, fully ballastless, and engineered for sustained 350 km/h operation. Among its most notable elements is the North Channel Bridge, with a main span of 450 meters. This makes it the largest span ballastless track cable-stayed railway bridge ever built. Nearby, the Middle Channel Bridge features a 3-tower cable-stayed configuration with 2 spans of 448 meters, another global first for high-speed rail. These spans are not remarkable only for their length. They are remarkable for their precision. Structures of this size are moving targets in wind, temperature, and tide. Keeping them aligned tightly enough for high-speed trains requires a level of control that pushes modern bridge engineering to its limits. The most extreme engineering, however, lies below the surface. To anchor these bridges in such an unstable seabed, engineers are installing massive steel piles drilled as deep as 160 meters below sea level. That is deeper than the foundations of many high-rise buildings and comparable to the anchoring depths used for offshore energy platforms. Steel was chosen over concrete for its superior resistance to corrosion and its ability to withstand the continuous dynamic loading caused by powerful tides. Installing these piles required entirely new construction techniques, with drilling operations carefully synchronized to tidal cycles and carried out from specially built offshore platform. In effect, temporary islands were created at sea, allowing construction crews to work in conditions that would otherwise be impossible. Cofferdams were installed and removed rapidly under high-flow conditions, minimizing disruption while maintaining structural accuracy. Hangzhou Bay is not just a challenging construction site, it is also a protected ecological zone. Parts of the bridge cross the Qiantang River Estuary Ecological Red Line, an area subject to strict environmental controls designed to protect fish migration paths and bird habitats. Construction windows were limited, and the natural flow of water and sediment could not be significantly altered. To meet these requirements, engineers developed low-impact foundation systems, fast installing temporary structures, and continuous environmental monitoring throughout offshore operations. Every major construction decision had to balance engineering necessity with environmental responsibility. Failure to do so would have risked halting the project entirely. Precision at this level could not be achieved through traditional methods alone. To manage construction in such a dynamic environment, engineers deployed advanced digital twin technology. A real-time virtual model of the bridge mirrors conditions offshore, fed continuously by sensors embedded throughout the structure. These systems track movement, load, alignment, and environmental conditions as construction progresses. From on-site workers to project managers miles away, everyone operates from the same live data, allowing immediate adjustments when conditions change. These systems were developed specifically for this project, marking a significant step forward in how large offshore infrastructure can be delivered. This is not the first bridge to cross Hangzhou Bay. In 2008, a major highway bridge opened nearby, dramatically reducing road travel times between Ningbo and the wider Yangtze River Delta. But the comparison highlights just how far this project goes beyond what came before. Where road bridges accommodate flexibility, this railway demands absolute precision. Where cars travel at highway speeds, trains here move faster than most aircraft during takeoff. With a designed service life of 100 years, this bridge is built not just for today's rail network, but for decades of future growth. Offshore construction officially began in 2023. By early 2026, major structural milestones had been reached, including the topping out of a 200-meter high main tower on the Northern Navigation Channel Bridge. As construction continues, the bridge is moving toward full structural connection before entering the final phases of systems installation and testing. The full railway is expected to become operational around 2027. When the first high-speed trains run across Hangzhou Bay, the impact will go far beyond saving time. This bridge will strengthen integration across one of the world's most powerful economic regions, shift long-distance travel from road and air to rail, and set new expectations for what high-speed rail infrastructure can achieve. For generations, Hangzhou Bay was an obstacle engineers worked around. Now, it is a corridor built on deep foundations, extreme precision, and the belief that even the most hostile environments can be mastered with the right combination of engineering and ambition. Thanks for watching Unthinkable Build. We'll see you in the next one.